Okay, so welcome back. So in this video we're going to do an example of calculating absolute error, relative error, and percent error. Okay, so let's say that a blueprint, let's say in a manufacturing blueprint there's a measurement, and let's say there's the stated measurement that they want, and so it calls for a measurement of 32.112 millimeters. So this would be the true or accepted value. Okay, that's what the blueprint calls for. Okay, so that's what we want. That would be perfect if we can get that, right? But let's say the part was measured, and this is what you got from the measuring device. Okay, so now what we're going to do is we're going to calculate the absolute error, the relative error, and the percent error for this. So again, absolute error is just the absolute difference between the two measures. So we take the absolute value of the measured value or the observed value, right, minus the true value. So in this case here, it's going to be 32,155 minus 32,112. Okay? And so in this case here, we get 0.043 millimeters. Okay? And so that's the absolute error. Okay? Now, what about relative error? Well, all we have to do is we take the absolute error and divide it by the true value. So in this case here, we're going to take 0.043, the absolute error, and we're going to divide it by the true value, which is 32.112. And so if we do that, what do we get? We get 0.001339. Okay. So that's our relative error. And now to change it to a percent error, all we do is just change it to a percentage by multiplying by 100% or moving the decimal point over to the right 2 spots and add in a percent sign. So in this case here, we would take the relative error, multiply by 100%, and what do we get? We get 0.13390633%. Now, as far as the percentage, so this would be rounded to, well, the precision here is out to the, what, thousandths place. So our precision here is 0.043. Okay, now here we got a rounded number, so we would round this to 0.001. Okay, and this would be rounded to 0.134%. Now notice that I did not round at every step of the calculation. I did not round in this part here, even though I didn't have to, okay, because it's absolute error. But here, I didn't round until the very end of my calculation. Here, I didn't round until I got my final answer. So that's another thing too, is avoid what we call round off error, okay, is to only round to the least precise measurement at the last step, okay? So other than that, that's all I wanted to mention. So again, this is how you calculate absolute error, relative error, and percent error.